How Earth's layers reveal forgotten epochs. We live on a planet that has forgotten most of its own story. Beneath every mountain, every grain of sand, and every ocean floor lies an archive, a record not written in ink or language, but in pressure, heat, and time. The Earth's layers are more than mere strata of rock and sediment. They are the chapters of a biography so ancient, so vast, that we have only read fragments. What we call history is merely the most recent line on the final page of a book that stretches back nearly 5 billion years. And yet, between those pages, something feels missing. Epochs erased, stories untold, civilizations that may have risen and vanished without a trace. For centuries, humanity has searched the skies for answers about our beginnings, while the truth may have been buried beneath our feet all along. Every layer of the Earth is a message, some clear, others fractured, some perhaps deliberately obscured. What if these layers are not just the memory of nature, but evidence of forgotten epochs, each one representing a world that ended and another that began? When we study geology, we think in terms of stability, mountains that stand immovable, continents that drift slowly. But the Earth is not still. It breathes. It shifts. It consumes itself and starts over. Entire continents have been swallowed by oceans, and oceans have risen to become deserts. Every few 100 million years, the planet resets, erasing almost everything that came before. And in those erasures, in those blank spaces of geological time, something extraordinary may have occurred. The rise and fall of worlds we no longer remember. What if beneath our cities, our rivers, and our forests lie remnants of civilizations older than the concept of humanity itself? What if the very crust of the planet hides evidence of intelligence that predates us, not in myths or ruins, but in the chemical and magnetic signatures of the rocks themselves? For too long, we've looked to the stars, assuming the unknown lies far beyond reach. But what if the real mystery is buried deep below, encrypted within the Earth's own memory? The story you're about to hear is not about speculation alone. It's about evidence, strange anomalies, impossible artifacts, and geological patterns that challenge everything we believe about history. It's about epochs that ended before ours began, and a planet that seems to be more than a stage for life, a participant, a recorder, perhaps even a designer of its own evolution. Because to understand who we are, we must first uncover what came before us. The truth, as it turns out, may not be lost among the stars, but sleeping within the ground we stand on. Before we uncover what the Earth has hidden for billions of years, take a moment to stay with this journey until the end. This isn't just another story about rocks or fossils. It's a descent into the planet's forgotten memory, and perhaps into our own. Subscribe if you wish to see what lies beyond the known, because once we start digging, the Earth might never look the same again. The time layers beneath our feet. When we look at the ground, we see soil, stone, perhaps the remnants of erosion. But beneath that quiet surface lies a world far older than any civilization, a vertical archive, each layer a fragment of time compressed by unimaginable pressure. The Earth's crust is not just geology, it's a narrative, one that holds the memory of creation, extinction, and rebirth. Every stratum we uncover is a page torn from an ancient manuscript, written in the language of minerals, fossils, and isotopes, a language that only recently we've begun to decipher. Geologists call it deep time, the scale of history measured not in centuries or millennia, but in billions of years. To grasp it is to confront our own insignificance. Imagine peeling away the surface of the planet like the layers of an onion. The uppermost layer, the one that holds all human history, from our earliest ancestors to today, would be thinner than the film of dust on a stone. Beneath it, however, lies evidence of worlds that existed long before us, ecosystems that thrived in alien climates, continents that collided and tore apart, oceans that evaporated and reappeared in new forms. Each layer tells a story, but also hides one. Beneath the Cenozoic, where mammals rose after the fall of the dinosaurs, lies the Mesozoic, a world of giants. Beneath that, the Paleozoic, home to marine empires and the first forests. And deeper still, the Precambrian, a time so vast and obscure that it accounts for almost 90% of Earth's history. a silent expanse from which only whispers emerge. Microbial fossils, chemical traces, mysterious structures that defy simple explanation. These layers are not static. They are dynamic records, shifting with tectonic motion, melting into magma, resurfacing as mountains. The Earth does not just store its past, it recycles it. And yet, this recycling raises an unsettling question. How much of the Earth's true history has been erased by its own hand? Entire epochs may have been ground into dust, subducted beneath continental plates, or dissolved in the mantle. If traces of our modern civilization were buried today, what would survive 10 million years from now? Plastic, concrete, radiation? Perhaps. But what if similar traces once existed, buried deep beneath older layers, remnants of a world before ours? The oldest rocks on Earth, some over 4 billion years old, tell a story of a planet constantly rewriting itself. In Western Australia's Jack Hills, tiny crystals of zircon, smaller than a grain of sand, contain isotopic signatures suggesting oceans and continents existed hundreds of millions of years earlier than once believed. These crystals survived cataclysmic bombardments, volcanic infernos, and planetary collisions. They are fragments of the first solid crust, the first memory. And within that memory, scientists find chemical fingerprints of carbon, hinting at the possible presence of early life at a time when, by all logic, the planet should have been sterile. If life existed then, what else might have followed? Could the early Earth have supported complex systems, biological or otherwise, that left no recognizable trace? The deeper we dig, the more we find anomalies. Metallic spheres embedded in ancient rock, magnetic patterns that shift inexplicably, fossil-like formations that predate known biology. Most of these findings are dismissed as coincidences or natural phenomena. But if even one of them isn't, then our understanding of the planet's layers changes completely. The Earth, then, is not merely a witness to time. It is an editor, a being that chooses what survives and what is forgotten. And if that is true, then perhaps the most important question isn't what we've discovered within its layers, but what those layers have chosen to hide, the great vanishings. Every few 100 million years, Earth performs an act of erasure. Species vanish, climates collapse, continents split apart, and ecosystems are rewritten from scratch. These are not simple extinctions, they are resets, abrupt interruptions in the planet's ongoing story. Scientists call them mass extinctions, but that phrase fails to capture their scale. These events are not just biological, they are cosmic, geological, chemical. They represent moments when the very parameters of life itself were rewritten, and everything that existed before was buried beneath the weight of a new beginning. There have been at least 5 of these resets, and perhaps more that we will never know. The most recent, the one that ended the reign of the dinosaurs 66 million years ago, is the best understood. An asteroid impact that plunged the planet into darkness. But the further back we look, the more mysterious these vanishings become. The Permian extinction, 250 million years ago, wiped out over 90% of marine life and 70% of all terrestrial species. It was the closest Earth ever came to total annihilation. Yet no single cause fully explains it. Volcanic eruptions, methane release, magnetic reversals, ocean acidification, each may have played a role, but none tell the full story. It's as if the planet itself decided to start over. And that possibility, that these resets are part of a pattern, not accidents, changes everything. Geological records reveal that these cataclysms follow a strange rhythm, a pulse every 26 to 30 million years. Some scientists have proposed external influences, a dark companion star orbiting the sun, clouds of interstellar debris, or even gravitational waves that periodically disturb the solar system. Others suggest the Earth itself has cycles of instability, driven by internal processes we barely understand. Whatever the cause, these vanishings remind us that the planet has been wiped clean more times than we can count, and that with each erasure, almost every trace of what came before disappears. But what if not everything was lost? Between the layers of devastation, subtle anomalies persist, traces of unknown isotopes, abrupt chemical shifts, unexplained magnetic signatures, markers that don't align with known events or life forms. Some geologists have noted microscopic metallic spheres and synthetic-like compounds embedded in strata far older than humanity. These could be natural formations, or they could be relics of something else, something that existed before the last great extinction. When we imagine extinction, we tend to think of species. But what if civilizations too have been erased, their existence reduced to mineral patterns and chemical residues indistinguishable from stone? The Earth's crust is a master of concealment. Under heat and pressure, anything can be transformed. Glass into crystal, metal into ore, evidence into myth. A world could vanish completely, and all that would remain are anomalies that confuse future scientists. The silence of the rocks, then, is deceptive. For beneath the smooth continuity of geological time lies a record of abrupt endings, moments when history was rewritten so completely that only the faintest echoes remain. To look into those vanished ages is to realize how fragile permanence truly is. Everything we build, every structure and monument, will one day be buried, crushed, and melted into new forms. The Earth remembers through transformation, not preservation. And yet, the idea of these cyclical resets invites a deeper question. Are they random catastrophes, or are they part of a broader design, an ongoing experiment in which life, intelligence, and civilization are tested, erased, and reborn in new configurations? Each layer of extinction might not mark an ending, but a recalibration, a cosmic trial repeated until the right balance is found. If so, then humanity's story is not the first iteration, but merely the latest. And perhaps, deep beneath the scars of extinction, the planet still carries the encrypted memory of those who came before, waiting for someone to learn how to read it. The hidden signatures beneath the crust. What lies beneath the crust of the Earth is not simply molten rock or ancient stone, it is a library sealed in pressure and darkness. Each layer of the planet hides a record of energy, chemistry, and transformation, a memory of every storm, impact, and eruption that has ever reshaped its face. But buried within that geological memory are anomalies, signs that resist classification, patterns that do not conform to any natural process we know. These hidden signatures may hold the key to understanding whether the Earth's history is merely a chain of accidents or something more deliberate. The deeper we go, the stranger it becomes. Beneath the continental crust lies the mantle, a zone of rock so hot and dense that it flows like an incredibly slow river. It moves continents, fuels volcanoes, and occasionally allows fragments of ancient crust, xenoliths, to rise to the surface. Some of these fragments contain minerals older than the Earth's oceans, dating back billions of years. Yet a few samples, recovered from deep drilling projects and volcanic eruptions, reveal chemical compositions that should not exist. Isotopic ratios inconsistent with known processes of planetary formation. In other words, elements that appear to have been altered by something beyond ordinary geological mechanisms. At first glance, these discrepancies might seem trivial, mere quirks of natural variation. But when these signatures repeat, the same anomalies appearing in rocks separated by oceans and epochs, they demand attention. Some geochemists suspect that these patterns may be remnants of materials that predate the Earth itself, perhaps from an earlier generation of planets consumed by the forming sun. Others entertain a more unsettling thought, that these anomalies could be artificial, the lingering trace of technologies or events long erased by time. Consider the presence of highly refined metallic spheres discovered in geological layers dating back hundreds of millions of years. Found in South African mines and other remote locations, these spheres display precision symmetry and composition inconsistent with known natural processes. Mainstream science attributes them to natural crystallization or sedimentary concretion, yet the debate persists. Could such objects be remnants of an earlier intelligence? One that understood the manipulation of metals before the Earth's current biosphere even existed? Magnetic anomalies add to the mystery. Across multiple continents, scientists have mapped regions where magnetic orientation within rock strata abruptly reverses or weakens without clear cause. While geomagnetic reversals are a known phenomenon, some of these irregularities occur in narrow, localized bands that defy the expected global symmetry. It is as if pockets of the crust were exposed to powerful artificial fields or subjected to processes that restructured their atomic alignment. When correlated with deep core samples, certain of these magnetic scars coincide with periods of rapid environmental change, and possibly mass extinction. But perhaps the most intriguing evidence lies not in the physical anomalies, but in the mathematical ones. Patterns of recurrence in isotope decay rates, cyclic spikes in mineral abundance, and the precise intervals between geological transitions suggest an underlying rhythm, as if the Earth's evolution follows a coded tempo, one embedded in its structure since its birth. Whether this rhythm is a product of cosmic mechanics or something else entirely remains uncertain, but the consistency is striking. Cycles of creation, collapse, and renewal repeating with eerie precision. If these patterns are natural, then nature itself operates with mathematical elegance bordering on intention. If they are not, then we may be walking on the remnants of an engineered world, a planet whose history has been written, erased, and rewritten countless times by forces we can scarcely imagine. What we call geology may be, in truth, the study of a coded language, one that the Earth has been whispering for billions of years. Every anomaly, every layer, every mineral out of place might be a syllable in that ancient message. We have learned to read the structure of atoms and the movement of stars, but perhaps the most profound story ever told is the one carved into the planet itself. A message buried so deeply that only now are we beginning to hear it. The lost epochs beneath the ice. For most of human history, we've thought of ice as a symbol of stillness, a frozen pause in the story of Earth. But beneath that silence, under kilometers of ancient glaciers and polar caps, there lies motion, memory, and buried time. Ice does not just preserve, it conceals. It is a mirror of the planet's most extreme transformations, locking within its layers a record of atmosphere, temperature, and even life from epochs we can no longer imagine. And in recent decades, as we've begun drilling into these frozen archives, what has emerged challenges everything we thought we knew about the timeline of civilization and the endurance of the Earth itself. Each layer of ice is a frozen echo. In Greenland, cores drilled deep into the ice reveal annual rings of snowfall dating back more than 100,000 years. But beyond that, in the Antarctic interior, the ice tells an even older story. There, researchers have uncovered evidence of atmospheric shifts and trapped gases from hundreds of thousands, even millions of years ago. Within those cores are not just records of climate, but hints of instability. Sudden warm spikes, unexplained increases in greenhouse gases, rapid reversals in temperature that occurred far too quickly to be explained by natural variation alone. It's as if something periodically intervened in the climate system, an event or a force that rewrote environmental conditions overnight. But what if the secrets beneath the ice go deeper than climate? Radar scans beneath Antarctica's surface have revealed buried mountain ranges and river systems, landscapes untouched by light for tens of millions of years. In some regions, anomalies appear: geometric structures, magnetic irregularities, and unexplained thermal signatures. While mainstream science attributes these to natural processes like subglacial volcanism or the flow of ancient ice, others wonder if what we've found could be the ruins of something much older. A civilization erased not by war or time, but by the slow burial of the planet's shifting axis. Throughout the geological record, ice has played a dual role: destroyer and preserver. During the Snowball Earth episodes roughly 700 million years ago, nearly the entire planet was entombed in ice for tens of millions of years. Life nearly vanished. Yet, when the ice finally retreated, it left behind conditions that triggered one of the greatest evolutionary leaps in history, the Cambrian explosion. Could such frozen ages be part of a repeating cycle, deliberate resets designed to purge and restart the experiment of life on Earth? If so, the ice is both the instrument of extinction and the archive of rebirth. There are even whispers from the margins of the scientific world about fossilized civilizations beneath the ice, traces of unknown materials, metallic fragments, and alignments too deliberate to dismiss as coincidence. While no verifiable evidence confirms these claims, the persistence of the idea points to something deeper in our collective psyche. The intuition that what is hidden beneath the Antarctic plateau is not merely geological, it is historical. The ice, like stone, is a storyteller. It remembers what the planet itself has tried to forget. And as it melts, faster now than at any point in human memory, it releases its secrets drop by drop. Microbes long dormant awaken. Ancient viruses re-emerge. Layers of air from extinct ecosystems mix again with the present. It is as though the Earth is unsealing its own archive, forcing us to confront not only our past, but the scale of time itself. If the ice were to vanish entirely, what else might we uncover? Mountain ranges, rivers, and perhaps, though we dare not say it aloud, evidence that the human story is far older than we've been taught. Every year, as satellites map the shifting ice shelves, new anomalies appear. Massive voids beneath the surface, unexplained heat signatures, perfectly circular depressions where none should exist. We explain them away with science as we should. Yet beneath those explanations lingers an unease. What if, beneath the oldest ice, we find not fossils but foundations? The ice is melting, and with it, the planet's most ancient secrets are awakening. What was once buried will soon resurface. The question is whether we're ready to understand what the ice has been trying to tell us. Echoes in the mantle, Earth's subterranean memory. Beneath the continents, past the reach of human exploration and light, there exists a hidden realm where time itself moves differently. A world of heat, pressure, and memory. The Earth's mantle is not an inert ocean of magma, as once imagined, but a living system, a slow, breathing organism of rock that circulates the history of the planet within itself. It erases, transforms, and records simultaneously. And within that deep, unseen world, there may be messages preserved not in language, but in the structure of matter itself, a geological memory imprinted across billions of years. Seismic waves generated by earthquakes and nuclear tests travel through the planet and return to us carrying echoes of its interior. When scientists map those echoes, they find anomalies, vast regions where sound slows down or accelerates unexpectedly, as though passing through something denser or more complex than molten rock. Two such anomalies, known as LLSVPs, large low-shear velocity provinces, sit beneath Africa and the Pacific. Each is the size of a continent and extends thousands of kilometers deep toward the core. Their composition remains a mystery. Some geophysicists believe they are remnants of ancient subducted crust, pieces of Earth's earliest surface recycled into the mantle. Others suggest something far more extraordinary, that they may be relics of a pre-Earth event, fragments of another planetary body that merged with ours billions of years ago. If true, the mantle could hold not just the memory of our world, but of worlds before it. That would mean that the Earth is not purely terrestrial. It is a fusion, a cosmic hybrid carrying genetic material of other planets long lost to time. But beyond this cosmic inheritance, the mantle also records the intimate details of Earth's own transformations. Within its mineral structure are isotopic anomalies, chemical fingerprints that appear and reappear at intervals matching major evolutionary and extinction cycles. It is as if the deep Earth keeps rhythm with life itself, pulsing in synchronization with biological and climatic changes above. Recently, scientists detected something even stranger: deep mantle plumes, columns of superheated material rising from near the core, that seem to form in periodic patterns. These plumes drive volcanic hotspots, trigger continental drift, and may even influence magnetic field reversals. But the periodicity is too precise to be random. Some models show a repeating cycle roughly every 30 million years, the same rhythm observed in mass extinctions, tectonic upheavals, and cosmic bombardments. Could the mantle be responding to external cosmic forces, gravitational waves, solar oscillations, or even galactic tides that ripple through the solar system, stirring the planet from within? This idea reshapes how we see the Earth, not as an isolated sphere, but as an instrument in a cosmic orchestra. Every note, every eruption, quake, and shift might be part of a larger composition, one whose source lies beyond the sun itself? If so, then the mantle is not merely a geological structure, it is a resonator, a recorder, a kind of planetary memory drive where the most ancient information is encoded, awaiting interpretation. Some speculative thinkers have taken this further, proposing that intelligence might not need to exist on the surface at all, that the planet itself could host a form of deep consciousness, expressed through cycles of creation and destruction. In this view, the Earth's mantle is not passive but aware in some way, adjusting its dynamics to maintain balance, to test resilience, to reset the surface experiment when necessary. Whether metaphor or reality, the notion of a living mantle forces us to reconsider the limits of what we call intelligence. If the planet can encode its own history in minerals, regulate its temperature through tectonic motion, and reset its biosphere when imbalance grows too great, then what separates mechanism from intention? We may be living on the skin of a being whose heartbeat we've only just begun to hear. And the echoes that return from the deep are not random noise. They are reminders that the Earth, beneath all its silence, remembers more than it reveals. The magnetic pulse. Earth's forgotten compass. Invisible, yet omnipresent, the Earth's magnetic field is one of the most profound mysteries in planetary science. A silent shield that has protected life for billions of years. It is the unseen architecture of our survival, deflecting lethal solar radiation, guiding migrations, and shaping the atmosphere itself. But beyond its protective role, the magnetic field holds a deeper secret. It records time, memory, and change. It is the pulse of the planet. And at intervals throughout history, that pulse has faltered, reversed, or vanished altogether. Each fluctuation leaves a cryptic signature in stone, suggesting that the story of Earth's magnetism might be inseparable from the rise and fall of civilizations and species. At the heart of this force lies the planet's core, a sphere of molten iron and nickel that spins like a dynamo, generating electromagnetic energy through motion and heat. This rotation is not constant. It fluctuates in cycles, responding to gravitational influences from the moon, the sun, and possibly even the other planets. What is astonishing is how closely some of these magnetic cycles align with major events in biological and geological history. The field has reversed itself hundreds of times, flipping north and south in a process that can take centuries, or occur abruptly within a human lifetime. Each reversal leaves behind a record written in lava and sediment, where iron-bearing minerals freeze in alignment with the field of their time, like compass needles pointing toward forgotten poles. When scientists map these alignments, they uncover strange regularities. Magnetic reversals often coincide with abrupt climate shifts, mass extinctions, and bursts of volcanic activity. The last major reversal, the Brunhes-Matuyama event, occurred about 780,000 years ago, long before recorded history. But recent evidence suggests that Earth's magnetic field has weakened dramatically in the past 2 centuries, particularly over a region known as the South Atlantic Anomaly. Could this mean that another reversal is approaching? And if so, what consequences might it bring for modern civilization, so dependent on technology, satellites, and digital infrastructure? The answer may lie in the past. Paleomagnetic studies reveal that during previous reversals, the field did not vanish completely. It fractured. Multiple poles appeared simultaneously, migrating unpredictably before restabilizing. During those chaotic intervals, cosmic radiation flooded the atmosphere, altering weather patterns and possibly influencing genetic mutation. Some scientists have even speculated that these periods of magnetic instability may have played a role in accelerating evolution or in erasing civilizations whose existence we no longer recall. Yet there is a deeper layer to this mystery. Some ancient structures, megaliths, temples, and burial sites, appear aligned not only with celestial events but also with regions of magnetic anomaly. Were these placements coincidental, or did ancient builders possess a forgotten awareness of the Earth's electromagnetic grid? If so, they might have understood something we are only now rediscovering, that magnetism is not just a physical field, but a living pattern, connecting consciousness, planet, and cosmos in ways we have yet to fully measure. Even stranger is the hypothesis that the Earth's magnetic field might carry information, a form of geophysical memory linking all living systems. Research into biomagnetism shows that animals, bacteria, and even human brains are influenced by geomagnetic fluctuations. Migratory birds lose their way during magnetic storms. Whales strand themselves when the field shifts. Human emotional and physiological rhythms subtly correlate with geomagnetic activity. Could it be that the planet's magnetic field acts as a global synchronization mechanism, maintaining coherence not only in ecosystems, but in consciousness itself? If the Earth's magnetism is indeed a planetary pulse, then every reversal may signify more than geological turbulence. It may represent a reset, a reordering of the energetic fabric that binds life together. In this sense, magnetic upheavals are not simply catastrophes, they are renewals, moments when the planet recalibrates, forcing life to adapt, evolve, or vanish. The compass we carry in our hands is a reflection of a greater compass beneath our feet, one that points not only north and south, but backward and forward through time. And as the field weakens once again, as the poles begin to drift faster than ever recorded, one question becomes impossible to ignore. What message is the planet's magnetic pulse trying to send? The crustal archives, when continents remember. The continents we walk upon are not static. They drift, collide, and fracture like slow-moving waves on a molten sea. Yet beneath their apparent stillness lies an archive, a living record of worlds that came before us. Every layer of rock, every mineral vein, every fossilized ripple of sediment tells a fragment of Earth's autobiography, written in the language of pressure and time. When we learn to read it, we begin to uncover not only the physical history of the planet, but perhaps the forgotten epochs that shape the very possibility of life and civilization itself. For centuries, geologists believed the continents were eternal, fixed blocks of stone resting on a stable planet. That illusion shattered in the 20th century, when the theory of plate tectonics revealed that continents move, subduct, and are reborn. But what most people never realize is what this implies. The surface of the Earth is continually erased. Oceans are swallowed into the mantle, mountain ranges rise and crumble, and entire civilizations, if any existed before us, could vanish without leaving a trace. The crust, therefore, is not just a surface, it is a palimpsest, an ancient tablet rewritten again and again by the forces of geology. In the oldest parts of the continents, regions like the Canadian Shield, Western Australia, and Greenland, scientists have uncovered minerals over 4 billion years old. Some contain chemical fingerprints of oceans that no longer exist, atmospheres long vanished, and conditions far too extreme for modern life. These deep time signatures hint that Earth has rebooted itself multiple times. The continents we know today may have been preceded by earlier configurations. Supercontinents like Rodinia, Columbia, and Pangaea Ultima, each rising and falling in a cosmic rhythm of creation and destruction. And in every cycle, something was preserved. Trapped isotopes, magnetic alignments, microfossils, or anomalies that don't fit the known sequence of evolution. Sometimes the crust records more than just natural processes. In regions such as the Middle East, South Africa, and South America, ancient rock strata show unusual metallic concentrations, traces of elements fused at temperatures higher than any known natural process could have achieved on Earth's surface. These findings are controversial, often dismissed as statistical anomalies or results of localized volcanic events. Yet they raise an unsettling question. Could there have been moments, long before written history, when intelligence, whether human, pre-human, or otherwise, interacted with the planet in ways now disguised as geology? Even the magnetic patterns of the crust add intrigue. Beneath the oceans, long symmetrical stripes of magnetized rock mark the slow birth of seafloor crust along mid-ocean ridges, stripes that flip polarity each time the magnetic field reverses. These magnetic fossils are more than data. They are the planet's heartbeat frozen in basalt. They tell us that every few 100,000 years, the Earth's crust undergoes global upheaval, a sign that what we call normal is merely one phase in an ongoing experiment. Then there are the anomalies that don't fit anywhere in the geological timeline. Ancient glass fields found in deserts that resemble the result of immense heat-driven explosions. Perfectly spherical metallic objects embedded in 3 billion-year-old rock. and the sudden appearance of complex minerals that seem to predate known tectonic or biological processes. Science explains many of these as natural phenomena, lightning strikes, meteor impacts, or slow metamorphic changes. But the deeper we look, the harder it becomes to ignore the whisper of an older narrative, one where the planet itself may have hosted cycles of intelligence, erased and reborn under different skies. The crust is not just stone, it is memory turned solid. Every mountain range, every volcanic plain, every ocean trench carries echoes of a forgotten sequence, epochs buried beneath epochs, civilizations beneath civilizations. To study it is to realize that we are not the first to shape the surface of this planet. We are merely the latest to add our layer, our signal, our trace to the ongoing archive. And as we dig deeper, the crust seems to ask a question of its own. How many times has the experiment been run before? How many layers of memory lie beneath our feet, waiting to be read before they are erased once more? The time fault, when the planet's clock breaks. Time, on Earth, is not constant. It flows unevenly through the layers of the planet, bending and breaking like light through water. We measure time by human inventions, clocks, calendars, atomic vibrations. But the Earth keeps its own rhythm, one far older and more erratic. Deep within its crust and core, there are faults not only of rock but of chronology, fractures in the record where time itself appears to stutter. These time faults are the geological equivalent of missing pages in a book, gaps so vast that entire eras vanish, compressed into a silence of stone. When scientists first began studying the age of rocks, they expected a seamless progression, a steady layering of sediment marking each moment in history. But what they found instead were abrupt discontinuities, layers millions of years apart pressed together as though time had folded. These are known as unconformities, places where the normal order of deposition has been interrupted by upheaval, erosion, or cataclysm. One of the most famous is the Great Unconformity, a global layer where nearly 1 billion years of geological history simply disappeared. Beneath it lie the ancient crystalline rocks of Earth's earliest crust. Above it, the relatively young layers that cradle the explosion of complex life. The question that haunts geologists is simple: what happened to the missing billion years? Some argue that those lost ages were erased by erosion during the violent breakup of a supercontinent. Others suggest they were obliterated by ice sheets or consumed by subduction into the mantle. Yet there are anomalies that refuse such tidy explanations. Around the world, beneath the Great Unconformity, traces of heavy radiation and isotopic signatures suggest that something more profound occurred, perhaps a series of planetary resets, each erasing not only the surface, but the chronology itself. If true, the Earth may have experienced moments when time, as a measurable process, broke down, when the geological clock stopped ticking, only to restart under new conditions. But what could trigger such a rupture in temporal continuity? Some researchers point to external cosmic events, massive asteroid impacts, gamma-ray bursts, or solar superstorms that temporarily destabilized the planet's magnetic and climatic systems. Others look inward, proposing that internal resonances between the core and crust, a kind of planetary heartbeat, can occasionally synchronize to a catastrophic degree, leading to global melting, tectonic inversion, and even the resetting of isotopic clocks. These would be moments when the planet itself forgets its own past, rewriting the memory of its matter as if beginning anew. More speculative thinkers have gone further still, suggesting that such temporal disruptions might not be accidents at all, but built-in mechanisms of renewal, geological fail-safes that prevent stagnation. If the Earth functions as a living system, perhaps it deliberately erases sections of its history to clear the way for new experiments in evolution and consciousness. The missing billion years would then represent not a failure of record-keeping, but an intentional silence, a planetary pause, a recalibration of existence. Even in modern science, there are echoes of this idea. Quantum physics teaches that time is not absolute, that it can dilate, stretch, and even reverse under certain conditions. If these principles hold true at the atomic scale, might they also apply in some unfathomable way to the scale of planets? Could there be moments when the Earth itself experiences quantum discontinuity, when causality blurs, when time ceases to flow linearly, and the geological record becomes a palimpsest of overlapping possibilities? Such questions may sound metaphysical, but their implications are real. Every time we drill deeper, we encounter new puzzles, isotopic ages that contradict one another, strata that appear older than the layers beneath them, fossils out of place in time. Either our measurements are flawed, or the planet's history is not as linear as we believe. Perhaps the Earth's greatest secret is not what it remembers, but what it forgets. The time faults that cut through its body are not just absences, they are transitions. They mark the boundaries between worlds, between what was, what might have been, and what had to be erased for life to begin again. If that is true, then every missing age, every vanished epoch, every silence in the rock record carries a message. That time, like the planet itself, is alive, capable of breaking, healing, and being reborn. The subterranean pulse, messages from the core. Beneath the continents and oceans lies a world we have never seen. A vast incandescent heart of molten iron and nickel, spinning faster than the planet itself, generating invisible storms of magnetism and heat. This is the Earth's core, the engine of our planet's life, the keeper of its secrets, and perhaps its greatest enigma. For all our technological progress, we have never directly observed it. Every measurement, every model, every theory about the core is built upon echoes. Seismic vibrations, magnetic fluctuations, and gravitational whispers that ripple through the mantle. It is as if the planet speaks from within, but only in coded pulses we have barely begun to decipher. In 1996, scientists detected something astonishing. By studying how seismic waves from distant earthquakes moved through the planet, they realized the inner core rotates slightly faster than the crust, about one extra turn every 1,000 years. This differential motion suggested that the Earth's interior is not a static sphere, but a living dynamo, a self-regulating mechanism that converts motion into magnetism. Yet more recent studies have revealed something even more perplexing. The core's rotation seems to slow down, even reverse, in periodic cycles lasting roughly 7 decades. When it does, the planet's magnetic field weakens, and subtle changes ripple across the surface, in atmospheric patterns, ocean circulation, even the length of our days. It is as if the heartbeat of the planet skips a rhythm, sending a signal through the layers above. The implications are profound. If the core's pulse truly governs magnetic strength, tectonic balance, and perhaps even climate stability, then our understanding of Earth as a passive host to life must change. We may be living on a body that behaves more like an organism, one that breathes, pulses, and renews itself according to deep cycles we have only begun to trace. But what drives these cycles? One theory points to gravitational resonance, the subtle tug of the moon and sun exerting pressure on the fluid outer core, modulating its flow like tides beneath the crust. Others suspect interactions between the core and mantle, where heat transfer creates complex feedback loops. Yet there are anomalies that remain unexplained. Certain regions of the core appear denser than others, hinting at hidden structures, perhaps remnants of primordial material from Earth's formation, or deposits of heavy elements drawn inward by unknown processes. Some even speculate these zones may represent the remains of an earlier planetary body consumed and incorporated during Earth's violent birth. Then there are the mysterious low-frequency vibrations, deep tremors that cannot be explained by earthquakes or volcanic activity. They emanate from the planet's interior, repeating in strange, rhythmic patterns. Some scientists believe they result from the movement of molten plumes. Others see them as evidence of something deeper. Perhaps the rhythmic oscillations of the core itself, a planetary heartbeat that sustains the magnetic field and regulates tectonic motion. In this sense, the Earth is not silent, it hums. It sings, in a frequency too deep for us to hear, but one that every living thing unconsciously feels. Ancient traditions may have intuited this truth long before modern science. Myths across cultures describe the Earth as a living being with a heart fire, a source of vitality and power beneath the surface. In Hindu cosmology, the planet is sustained by an inner energy called Agni, the sacred fire that keeps creation alive. In Greek lore, the forge of Hephaestus burned beneath the volcanoes, shaping the destiny of gods and men alike. Even the indigenous peoples of the Americas spoke of the Earth's heartbeat, a rhythm one could feel by pressing an ear against the ground. What if these were poetic reflections of a very real geophysical phenomenon? An ancient awareness of the planet's pulse expressed through myth long before it could be measured by seismographs. In recent years, researchers have discovered that the Earth's core might be cooling faster than expected. If true, it raises an unsettling question. What happens when the planet's internal engine begins to fade? Without its molten motion, the magnetic field would collapse, stripping away our protection from cosmic radiation. The atmosphere could erode, the oceans evaporate, and the planet could become as barren as Mars. Yet, as with every planetary cycle, decline may not mean death, only transformation. A new equilibrium might emerge, one beyond our comprehension. The subterranean pulse reminds us that the surface world, the forests, the cities, the oceans, is only the skin of a far deeper organism. Beneath us beats a rhythm that has endured for billions of years, shaping everything we call life. And if we could learn to listen to it, perhaps we would hear not just the memory of Earth's past, but the whisper of its future. The memory of stone. Earth's last message. Every planet tells a story, but few realize that the story is written in stone. Rocks are not dead matter. They are archives of pressure and light, crystallized memories of everything this planet has ever endured. Each grain of sand, each mountain ridge, each fossilized shell is a record, not just of geology, but of time itself. And in the stones beneath our feet lies a mystery that transcends all human history. If Earth could speak, what message would it leave behind for whoever comes next? When scientists analyze ancient minerals like zircon, some over 3 billion years old, they find chemical fingerprints that predate the moon's final formation. These minerals carry isotopic scars from an age when the planet was still molten, when asteroids rained down like a cosmic bombardment, and when the first water condensed into oceans under skies of fire. Every atom inside them has been rearranged countless times by heat, pressure, and radiation, yet the structure endures. Zircon, in a sense, is the DNA of the Earth, a molecular witness that has survived all extinctions, all supercontinents, all rebirths. But not all stone memories are so ancient. In the fossilized layers of coral reefs, we find the oscillations of climate recorded in calcium carbonate. In volcanic glass, we see the rapid cooling of planetary trauma. In magnetic rocks, we read the shifting poles of the planet, the moments when north became south and chaos briefly reigned. It is as if the planet itself keeps a journal, inscribed not in ink, but in crystal alignments and isotopic ratios. Yet the deeper we read, the more we realize something haunting. Most of Earth's past has been erased. Entire civilizations of stone have crumbled, recycled, or vanished beneath the sea. For every record that remains, 1,000 have been swallowed into the mantle's dark archive. If we are not the first intelligent species to rise on this world, then those who came before, if they existed at all, would have been devoured by time's geology. Their monuments would have eroded, their metals oxidized, their traces subducted into magma. Only the most durable materials, ceramics, synthetic crystals, or engineered isotopes, might outlast 1 billion years. And perhaps, scattered somewhere in the crust, such relics already exist, waiting for a future intelligence to find them and wonder who we were. Even now, humanity is leaving its own geological signature. The thin layer of plastics, radioactive isotopes, and carbon residues we have dispersed across the planet will become a permanent scar, a techno-fossil horizon marking our brief moment in deep time. Future geologists, whether human or something else, will find this layer and know that a civilization once lived here, one that reached for the stars while struggling to understand its own planet. It will be our final message, a sentence in the Earth's memory, preserved long after our voices are gone. But perhaps the message is not just physical. Perhaps the Earth itself, through its cycles of creation and destruction, carries an encoded pattern of intelligence, one that transcends biology. The rhythm of tectonic drift, the oscillation of magnetic fields, the pulse of volcanic renewal, these are not random. They are the syntax of a living system. To read the Earth's stones is to glimpse the algorithm of a consciousness vast enough to shape continents and subtle enough to nurture life. Some scientists now explore the concept of geological cognition, the idea that complex feedback systems within a planet can behave like a primitive mind, one that learns, adapts, and even remembers. If that's true, then the memory of stone is not passive. It is active, self-referential, and evolving. Every extinction, every eruption, every climatic shift is a form of planetary thought, a recalibration in the grand computation of existence. And if the Earth itself is thinking, then perhaps the greatest question is not whether it remembers us, but what it will do with that memory. Will our era be archived as a warning, a failed experiment in consciousness? Or as a necessary step towards something greater, a planetary awakening where the biosphere itself becomes aware of its own history? The stones will decide. When the oceans recede, when the last city crumbles, when our satellites fall silent and our monuments turn to dust, it will be the rocks that carry our story forward. Long after the last human name is forgotten, the Earth will remember, not in words or images, but in strata, minerals, and the eternal whisper of stone. Reflection and closing message. We have journeyed from the molten birth of the planet to the pulse of its hidden core, from the mysteries buried in its layers to the silent intelligence encoded in stone. And as we look back, a realization begins to settle. The Earth is not just a place. It is a story, one that began long before us and will continue long after we are gone. Every mountain, every ocean, every grain of dust carries the memory of something greater, the persistence of life in the face of endless transformation. For billions of years, this world has been writing, with fire, with water, with pressure, with time. The continents have drifted like pages turning. Civilizations, species, even entire ecosystems have come and gone like chapters, each adding a fragment to an unfinished epic. And now we find ourselves at the latest line of that story, reading backward into the depths, trying to understand what the Earth is trying to tell us. Perhaps what we call science, all our measurements, theories, and models, is simply our attempt to listen, to translate the language of shifting crusts and vanishing epochs, to hear the meaning behind earthquakes, climate cycles, and magnetic reversals. But even as we listen, we realize how small our time is, how fragile our understanding remains in the shadow of cosmic scales. For every answer we uncover, new questions emerge. How many epochs have been forgotten before ours? How many civilizations might have risen and vanished beneath our feet? How many times has the planet reinvented itself in silence? The deeper we look, the more the Earth resembles a living archive, not only of matter, but of experience. It records not just what has happened, but how it feels to endure. The weight of pressure, the flash of heat, the patience of erosion, all are expressions of resilience. And in that resilience, there is wisdom. The Earth is not fragile. It is adaptable. It knows how to fall apart and begin again. And maybe that is the lesson we were meant to learn all along. Because humanity now stands at a threshold of its own making. We have the power to shape this planet, but also to destroy it. We have altered its atmosphere, shifted its rhythms, carved our name into its crust. The question that remains is whether our story will be one of harmony or hubris, whether we will become a part of Earth's long memory or just another erased experiment in the sediment of time. If the layers of the Earth could speak, perhaps they would not warn us. Perhaps they would remind us that every collapse is a beginning, that extinction is not failure, but transformation, that the universe itself seems to favor renewal, the endless rewriting of what was into what might be. And so, as this journey comes to an end, we are left with a single truth. The story of Earth is not separate from us. It is us. We are its surface thoughts, its brief awareness, its latest attempt to understand itself. The rocks beneath us are our ancestors. The air we breathe is their legacy. And someday when our time has passed, the planet will fold our memory into its next chapter, one written not by hands, but by the slow, deliberate movements of time. So, if you've reached this point, stay. Don't just watch. Listen. Let the silence of the earth remind you of your place within it. Subscribe not just to this channel, but to the search itself. The search for meaning in the vast and ancient dialogue between life and planet, between consciousness and stone. Because the deeper we look into the earth, the more clearly we see ourselves. And perhaps, in understanding it, we might finally understand what it means to exist.